Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world.
So welcome to today's show, and we've got a really exciting guest, one of a very small group of people who have volunteered or been conned into coming onto the podcast more than once, so I must have done something right. But big welcome to Isobel Sheldon, the Chief Strategy Officer from Britishvolt. She appeared on the podcast a while ago now, over a year ago, a long time ago, in a previous role at the UK Battery Innovation Centre, but has since then moved on to Britishvolt, where she's been for some time now. So welcome to the show, Isobel. We'll get going.
Thank you, Ryan. It's the first time I've been called an exciting guest, so that's a first for me.
What? No, you are an exciting guest. It's always a pleasure when I see you around and about at industry events, and I saw you talking a little while ago and asked if you do this, and you very kindly agreed to come and talk about what's happening at Britishvolt. I was just thinking that my brain went on the fritz, but it's quite some time since you moved on from the UKBIC to Britishvolt, isn't it? You've been at Britishvolt for a while now.
Yeah, it's just over 2 years now.
Wow.
So I was the first person into the company, and my official start date was 1st of July 2020. So it's just over 2 years now.
Wow. So as sort of customary, if you could give us a quick kind of overview of yourself and your background and how you got to be doing what you're doing, that would be really good.
Yeah, sure. I mean, I've been in the EV battery industry for something like 20 years now. Started my own startup company in 2002, 2003. And pretty much nobody was doing that then. There was probably half a dozen people around the world, maybe a dozen people around the world that were looking at this. And I was working in the automotive industry at the time, and I happened to find myself in the Toyota Technical Center in Japan, in Nagoya, looking at the first generation Toyota Prius and thinking, that's interesting, but I'm sure we can do a better job. So I came out of my job working for the Tier 1 and set up my own company and pretty much developed what became the world's first commercially available plug-in hybrid, which was a conversion of the Toyota Prius. And we didn't do anything with Toyota; it was done totally independently.
Oh.
And I ran that business for 10 years, developing battery systems for high-performance vehicles, large buses. Did some fleet trials with some of the automotive industry in the UK. And then the global financial crisis sort of really kicked in from 2008, 2009, and we had enough opportunity and enough contracts to keep going till about the back end of 2012. But as the R&D spending dropped off dramatically, we had to close the business before it completely ran out of money.
Yeah.
And that was really sad because it's 10 years of my life and 21, 22 people worked for me at that particular point in time. So very hard times.
Yeah.
But I wasn't on my own in the world. Lots of businesses were struggling to survive at that time. And then I ended up joining Ricardo as one of their battery specialists and then moving on to Johnsson Mathey battery systems before moving on to UKBIC. So I was the engineering and technology director at JMBS. And when that business was sold to Cummins, I transferred across and helped them integrate it into their business before moving on to UKBIC.
Ah, and then from UKBIC to what has become a massive adventure, like a huge story at Britishvolt. And as you mentioned earlier, you were the first employee there. How did that come about?
Well, it was an inquiry that was passed to me by the APC, because the Friday Battery Challenge and UKBIC and APC, we all worked very, very closely together. And it came to me as an inquiry about setting up a battery facility, a battery manufacturing operation in the UK, and being the business development director at UKBIC. Naturally, that was passed across to me. And there was a lot of ambition, maybe quite a bit of vision that was being manifested into the early stages of a plan. And it seemed to me that here was a couple of people that had a great idea, but not much experience in the battery industry. And they needed somebody with a long history in the battery industry to steer this in the right direction. So over the first 2 to 3 months of those conversations, that's when it was decided that perhaps I ought to join this new venture and provide some of the backbone in the battery industry and the connections out to all the key people in the industry to start building a team to try and get this up and running.
Ah, cool. And so then for people who don't know, although, I mean, you'd have to be living under a rock, particularly from the UK if you've not heard of it before, but what is Britishvolt?
So Britishvolt is a battery cell design and manufacturing company that was started just over 2 years ago. And really our ethos is to look at the 4 market failures in the battery industry. And those are capacity, technology, ESG, and material supply chain. And I think it's pretty clear from the uptick in EV adoption over the last couple of years, it's really started to take off. There isn't going to be enough battery manufacturing capacity in the world to meet those ambitions. So adding in capacity is really, really important. And we have 44 gigawatt hours worth of capacity going up in the UK, and another 47 to 50 gigawatt hours potentially in North America. And we're talking to the Canadian authorities about that at the moment. But also, it's not just about building battery manufacturing capability. It's about developing the cell technology. And the second market failure is the technology market failure. In the past, the battery industry has been built on a one-size-fits-all strategy because it's a scale game. You have to build in large quantities to get the economics right. And the history of the EV industry has meant that in the past, EVs have never sold very well. Therefore, you've had to sell a small range of cells to as many automotive OEMs as possible to build up the volumes. Yeah. As we're moving forward into this more significant electrified future, we can now start to do more customized and tailored cells, which are respecting brand values and brand attributes. And we're starting in the sports car sector, but moving into the performance end of the mainstream automotive OEMs pretty quickly now. And really the one size fits all strategy hasn't really supported those application requirements. Same thing at the commercial vehicle sector end. It's all leveraged passenger car cells, and passenger cars spend 90% of their time doing nothing, whereas a commercial vehicle spends 70% of its time trundling around and being charged and used fully every single day. So clearly total cost of ownership and life cycle is really important. And at the moment, there's nobody really domestically or locally manufacturing in Europe or North America to support that industry either. So they're completely underserved. They're white spaces. Yep. And as we move into those with local manufacturing, we really don't have a tremendous amount of competition in those market sectors. So that's a good place to be. ESG is another one. That's the third market failure. The industry is pretty much grown from where it started 15 or so years ago. And nobody's really thought about the embedded carbon content and how we can drive that down. So the numbers on that are, if you buy your cells from China, it's about 96 kilograms per kilowatt hour of embedded CO2. If you take a global average, it's about 66 kilograms per kilowatt hour, and we're targeting 25, so about a quarter of Chinese emissions and a third of the global average. We firmly believe that you need to have a sustainable company making products in a sustainable way to service a sustainable industry moving forward. That's what electrification is all about. And then the fourth market failure is, of course, the material supply chain. And we've got very high prices at the moment, but we're working very closely with supply chain companies to ensure that when we launch our facility, we have materials at the right place, sustainably produced, that we can put into the battery facility to produce sustainable products. Based on the first 3 market failures. So that's fundamentally where we are as a business.
Oh wow! You know what? We've spoken a few times, and I've seen you present Britishvolt a couple of times, and I'm not sure I've seen you talk in that way about it. That's a really interesting way of putting it. The 4 kind of failures that you're addressing, and I can relate to all of those. So one of the things, like as a project or as a company, you know, the battery cell market tends to be dominated by big companies because of where it's at and the costs of doing these things. You've got your LGs and you know, Muratas and Panasonics and these sort of mega corps with revenues like a small country, basically. Where does you know, Britishvolt, where does that kind of, as a startup business, how do you get yourself into that position where you can compete against that sort of players? And who even, you know, it's not something that we really do in the UK. It's like trying to launch a very big company. We try to launch little companies and sort of small cottage industries and things. Like where did that side of it come from? That sort of the ambition to compete at that very large scale?
Well, I mean, you're right. In the UK, we're used to doing things on a small scale and on a shoestring budget. And that's been typically where UK industry has been for a long time. But really what that's done is it's armed us with the skills as a nation to be careful with, you know, investment capital and to spend it wisely and efficiently. So we've learned those skills over the last 30 or 40 years on how not to waste money and to maximize the opportunity in front of us. I mean, really, if you look at the big 6 manufacturers, they're really struggling with an existing infrastructure, existing manufacturing operations, existing supply chains. And it's very, very difficult for them to pivot that, considering the hundreds and hundreds of millions of dollars they've spent in setting it up, into a slightly different view of the future. So that tailored and customized and low CO2 strategy that we've put in place, we can only do it because we've had a blank sheet of paper in front of us. We've had an opportunity to reimagine a manufacturing solution for cells. And if you're sat there with 10 facilities under your belt that are already cemented into the ground, if you want to really consider changing the tack of the company, you've got to reinvest hundreds of millions of pounds all over again, which clearly isn't doable. And as we went through launching into the startup phase, and we're coming out of that now. We're now into the scale-up phase because we're actually putting, you know, facilities in place and we're starting to produce stuff now. If you really want to stand out from that crowd, you have to do things differently and you have to create a different approach. Otherwise, you just end up in a very much a Me Too situation. So we needed to focus on technology and providing performance, providing products that people actually wanted to have put into their vehicles. Enable vehicles to behave in a way that they haven't been able to behave before, and really to capitalize on that opportunity, because these 2 market sectors we've chosen as our entry points aren't really that small. If you look at the commercial vehicle sector, it's like 150, 200 gigawatt hours by 2030. And if you look at the, you know, any automotive application over 350 horsepower, it's going to be around about 700 gigawatt hours worth of demand by 2030. So there's a terawatt hour of demand almost to go out there. And at the moment, nobody's looking at it because they're all stuck in that one size fits all. Let's serve the mainstream automotive industry. So that's where we differentiate ourselves and do things differently.
And one of the big challenges in the UK, I mean, you mentioned that we're really efficient with capital. That's a very nice way of putting the struggle with access to capital that we have for business. So there's always this sort of weird paradox that UK is sort of the financial center of the world for a sort of investment banking and whatnot, but actually it doesn't really invest in business in the UK. And so a project like this of a sort of startup business of, you know, immediate unicorn and billions of investment and stuff just doesn't tend to happen here. How have you guys kind of attacked that and managed to fix that particular part? Because that the access to capital is a really key enabler in the whole thing, isn't it?
Yeah, it is. I mean, you have to think about a funding plan and how you're going to do this. And it's not all just about capital, it's about having a string of fundraising opportunities in different areas. So there could be debt involved, there could be equity involved. Obviously, government grants are important in signposting the validity of a plan. And of course, we've now got confirmation, 100% confirmation of the 100 million non-repayable grant from UK government.
Yeah.
And that's not an unusual approach. And it's been done in various different locations around the world. To get the government to back you, the capital flows, you can raise the debt. It's a standard model of fundraising.
Outside the UK.
I think well, outside of the UK, but also in the UK too. I think that UK funders are really interested in what this energy transition is going to mean. Fundraising, as you well know, Ryan, is always difficult and always challenging, and especially at the moment in the current geopolitical arena. It takes longer to get those investors over the line. But we're not just focused on UK entities to raise the funding. It stretches right around the world, from the Far East, sort of places like Malaysia and Indonesia, through to the Middle East, where there's a lot of investment capital, a lot of risk capital, to the US, as well as European funding bodies as well. So it's a real mix. And really, the only UK relevant part of it is that the first facility is going to be here in the UK. It's not just serving UK interests, it's going to sell right across the European geographical area. Yeah. And then the second facility will be based in North America. So this is a global proposition with the UK core IP element, which is important to understand.
Cool. Fascinating. So if we kind of move on then to talking about the technology, and there's a couple of things happened recently that were really interesting with what you guys have done. One of those was the acquisition that you announced recently, which gets you into manufacturing different format cells. So could you tell us a bit about that?
Yeah, clearly, I mean, there's a real focus on larger diameter cylindrical cells. And some of our premium automotive customers are very much looking at the 46 diameter cell as a potential. Yeah. And we call it the 46XX because different customers want different lengths. So we go from 70 all the way through to about 105. Oh, wow. But maintaining that flexibility means that you can have technology that's relevant parametrically to a wide variety of different automotive OEMs, and you can do different things inside. Which gives you the performance benefits that we're looking at pushing out into the market that are in development now, and they're looking pretty good. In addition to that, we've got a 26 and 28 millimeter diameter cells, and we'll be choosing one of those diameters moving forwards. But that gives us some specific advantages in the relationship between energy and power, which has always been a real challenge for battery technology. You can do one or the other, and we figured out a way of doing both. So, a high capacity cell that competes with the best on the market, that can deliver 10C peak discharge and 6C continuous discharge, and charge times in between 12 and 13 minutes. These are game-changing metrics that our customers are looking at and saying, actually, this is market-leading technology. We need to have those in our vehicles. Yeah. So we found a lot of those skills and an existing product portfolio that could be adapted and modified within EAS, and it seemed make an awful lot of sense for us to go and pick up that company and the people that work in it, and provide the ability to scale those products through to volume manufacturing, which is something they didn't have the opportunity to do before, which has been really attractive, not only from our product portfolio perspective, but also from the EAS's team perspective, because they finally get the opportunity to see their products going into the mass market, which is really interesting for them.
Yeah, I can imagine, because actually that business has been around for quite a long time, hasn't it? It's not sort of in one shape or another. Yeah.
It used to be called Gaia many years ago, the Gaia battery facility in Germany. So yeah, a lot of experience and a lot of history there.
And that's another key element. So it gives, as a business, it gives you a toehold in Germany, and and some access to some good R&D capabilities there. And what exactly was it that they had? Was it sort of production technology or a particular kind of cell construction like what was it that they had that was really appealing?
Well, it was really a combination of all of those things, really. If you're going to be making large diameter cylindrical cells, you need to control the manufacturing process really, really carefully. And I think Tesla has obviously come to understand that over the last 12 months. So the manufacturing techniques and some of the key capabilities that they offer at the scale that they're at the moment has meant that they have demonstrated the ability to control that manufacturing process at a certain scale. So it's a really, really good starting point to move that into mass manufacturing. That's something that has been developed at EAS. That's something that we want to adopt in later phases of the facility once it's been optimized. And things like bipolar battery technology, whereby we can ditch a lot of the containers and the casings of cells and make super cells. That's highly relevant for chassis integrated battery systems, for example. So there's a number of things in the background as far as the IP that we've picked up is concerned, that will be highly relevant to a lot of our customers moving forwards as we try to put improved EVs on the road and give better performance.
Okay, cool. And I mean, that my next question was going to be about you probably answered it there, but it's maybe not the answer that I was hoping for. So there's this debate about cylindricals or prismatics, or the very large format cell to pack type cells, and I've been known to be like, no, cylindricals is the optimum format, and I really like cylindricals, but I'd got shouted down the other day. Someone was like, no, prismatics, and all the OEMs are going prismatic, which actually I don't think they are. I think they're more. So what's your kind of 2 cents on that? Where do you see cell format going in the future? And I'm guessing at least in part it involves 46XX type cells for some applications. But where do you see it going?
Well, I see the larger format cylindricals as being a major push over the next 4 or 5 years. So clearly moving into 26, 28, 46 diameter cells with varying different lengths means that we can capture an awful lot of application requirements that you probably couldn't do with the 21700 that weren't really practical. We're still doing the 21700 because it's much easier and very well understood to get to a product that we can sell in the market pretty quickly. And we have customers. I mean, our first pre-offtake agreements are already in, which reserves our entire first phase capacity. So that's now gone, and we need to build further capability to be able to supply other customers that are looking for 21700s. But the other format that's really interesting to us is the prismatic format, and that's really applicable into the commercial vehicle market. And we have development activities to get to our A samples and B samples as fast as possible, because we have customers who are working with us and will be looking to place offtake agreements for those cells in the coming 12 months. And in particular, if you look at some of the low cobalt or no cobalt solutions that we have outside of China, we don't really have any direct competitors for those in prismatic format. So it's a clear white space and clear water for us to go and play in and actually get cells out into applications, and everybody else is going to be playing catch up with us. I mean, we're moving really fast as a business, especially on the product development front. We're about half the time that a company like LG or Samsung would take to develop a product and get it out to market.
Wow. So you are, there isn't a sort of a winner for you between the prismatics and the cylindricals. There's just different applications for both prismatics in commercial vehicles, cylindricals in passenger vehicles, different sizes. That's really interesting. You sort of got in there subtly that all of your production initial production capacity has been booked out in these offtake agreements. That's really interesting. How long will it take? So you get your sort of first production up and running. How quickly do the prismatics follow through? How long will that take to get prismatic products up and out in the market?
So we're putting in place a scale-up facility, and that will be operational sort of third quarter of next year. And that gives us the ability to make C-sample products and get it out to customers for use in vehicles. So we'll be selling product from 2023 onwards, which really does bring that revenue opportunity significantly forwards. And part of that pre-offtake agreement that we've already got is as much as you can sell, we will take. As much as you can make, we will take.
Yeah.
Kind of agreement. So that's really, really positive. And we'll be adding in a second line in that scale-up facility towards the end of next year. And that's probably going to be large format cylinder core cells, but it could also be prismatic depending on who comes and reserves capacity next. So that really is the start of it. And we will be revenue generating from 2023. The main facility probably won't be at full flight production until sometime in 2025. The equipment will get bolted in, you've got to commission it, you've got to optimize the process, of which the scale-up facility really helps us to do that, and means that we won't be wasting as much product as we get the yield rates up through the scale-up facility. But we'll train all our staff in the scale-up facility, and by the time they get into Camas and start operating the really big stuff, or the multiple versions of what we'll have in the scale-up line, the people will already be able to press the appropriate buttons and twiddle the right knobs and be familiar with the equipment, which means that we can optimize and scale up and ramp up production pretty quickly compared to doing it on a main line from the offtake.
And that is so another interesting part of your business. You've got the big factory that everyone will see, which is in Northumberland, in Camas, which we've talked about before, and sort of where my family are from originally, so it's quite nice to see that going in there. But you've also got this other facility, scale-up facility, like research. Is that the same as your research and development, or is there a third? There's those two facilities basically in the UK, and that's in the Midlands, isn't it?
Well, it'll be three facilities, because our R&D facility will go in, and that's going into Leamington Spa. So the R&D and the scale-up is being kept in the West Midlands area, and really because there's existing talent in the industry that we can tap into. And of course, it's the heart of the automotive industry in the UK, so it makes sense to do that there. So those two facilities will be really doing the early stage R&D development and getting through into volume, and then we'll just transfer direct up to Camas to make sure that we get into large scale giga kind of volumes as smoothly as possible. It's all about de-risking the business. It's all about making sure we give ourselves as few surprises as possible. And when you're dealing with automotive customers, including the big blue chip companies, and we're talking to all of them, they like to see de-risk plans for industrialization. So that pilot scale facility is absolutely critical to make sure that we can demonstrate milestones and waypoints that we can hit, and hit in a realistic way to give them confidence that as we get into production, we're going to be able to provide the kind of quantity of product they're looking for.
Okay, cool. So you'll have 3 UK facilities: R&D, scale-up production, and then series production. That's really cool. I've heard people talk about the challenges, because battery manufacturing is this sort of very continuous process, very hard to control, and once you've got a plant in production, you don't want to mess around with it, basically. So it makes sense in terms of scale up elsewhere. Or, is there a reason to not have it on the site, or is it just that the big factory is going to take such a long time to build that you've got to kind of concentrate on that in that location and get up and running in parallel with the scale up and the other stuff elsewhere? Or is it just the skills and things?
Well, it's a combination of all things, really. Obviously, if we're building the 4th largest building in the UK, that takes quite a bit of time to pile all the ground. And there are certain things that you need to do for the whole facility that you can't do in stages. So piling is one of them. you couldn't build phase one, get it up and running, and then start piling the ground next door, because you've got very accurate coating technology that would be disturbed, and having ripples in a anode or a cathode coating on a foil isn't very good for durability of your cells or performance. So there were certain things that we have to do in one go, and setting up some of the infrastructure for the whole facility means two things. One, your timescales are slightly longer than if you were just building a discrete part of it. And number two, you have to deploy a little bit more capital to be able to get those things in place. So that does take some time. And, we didn't want to have a huge gap in between the back end of the R&D capability in time before we got up to Camas and started producing it in very large volumes. So the pilot line really does slot into that gap and make sure that we've got a continuation of activities from the materials down selection through to the cell designs and development, through to scaling up, through to manufacturing at Camas. And then really, it's about the availability of facilities to be able to put the pilot line into. At the Hams Hall facility, the shell and core of the building was already there. So it's a matter of going and agreeing a lease rather than just building it from scratch. We'd much rather not take up existing free space if we can. I mean, you have to for a big factory, you've got no choice because they're huge. But the other facilities we need to choose from what's already there. And we found two really superb buildings to house those two facilities in.
Oh, fascinating. So then we're progressing on three fronts, and it's really clear how all that's coming together. And you mentioned something again, just sort of in passing earlier, about cobalt free. So I wonder if you could just sort of expand on that a bit more in terms of what you've got coming on that front, because cobalt's a contentious ingredient for battery cells. Some terms of how it's handled and produced and things like that. So getting rid of it is a really good thing to do.
Well, getting rid of it is really hard because you need the cobalt for stability reasons. And I don't know a company yet that has successfully demonstrated a high nickel material with zero cobalt in it. I don't think that's been done yet. Not a practical way anyway. There's lots of theories about how it could be done, but nobody's demonstrated it so far. So reducing cobalt is really important, going for a high nickel, low cobalt mix, and then looking at the cobalt supply chain instead of turning our backs on places like a DRC, because if you do that, you just chuck a load of people out of work, people that feed and educate their families and their children. Let's work with the DNOs on the ground and try and improve the working conditions, really stamp out child labour, provide the IT systems that gives you proper traceability, and you can improve the health and safety. So really lift all boats as much as we can, because that's the point of what we're all trying to do. We're trying to create a better environment for everybody, and that means all the way upstream in the supply chain too. However, high nickel doesn't provide all of the solutions for all of the applications, and we've already said that one size fits all isn't going to work or be fit for purpose moving forwards. So you need solutions that are higher durability, higher cycle life for things like the commercial vehicle sector and off-highway applications, but also for things like stationary energy storage. So you would typically go for a lower energy dense solution, which may be an LFP, for example. But you are giving quite a bit away in energy density. You're coming down from, we'll be in excess of 300 watt hours per kilo in our prismatic cells, about 308. If you've got an LFP cell, it's in between 180 and 200. So it's about 2/3 the capacity. But there are things you can do with the more advanced phosphates and add in different materials that can start to bring that up to about 240, 245 watt hours per kilo, which again will give us a competitive edge in the market, but still give us the durability that we need to service things like the commercial vehicle sectors.
Okay. So you see there being a place in this sort of future market for LFP technology alongside your different blends of NMC as well?
Well, I think LFP is only the starting point. I think you have to go to a more advanced phosphate for it to be widely adopted. Okay. And that's the path that we're taking.
Okay, interesting. So it's a sort of special blend, if you like. And that
je ne sais quoi involved.
Okay, yeah, I can imagine. That's really interesting because we've seen lots of people talk about LFP. Seen Tesla bring it back into some of their vehicles because they had the space, so they could sort of live with that lower energy density. But I have wondered what the direction of travel would be in the industry as to whether or not it would just sort of eventually fade out in new applications. But it does seem to having these resurgences and finding new places where it's useful, which I guess a lot of that is driven by the kind of challenges with NMC type technology. Do you think that's where it fits in?
Well, yeah, I mean, if you think NMC is really good for long range, and we've got a situation at the moment where the price parity with internal combustion engines is still a thing. Beyond 2035, that's no longer a thing, because if you can't buy an internal combustion engine, there's nothing to compare it to. But people are still really focused on range when they go into a showroom, even if they don't need it. If they only drive 30 or 40 miles a day, they're still, I need to go 400. I think the electric vehicle market will mature over time, and people will start to understand that they're spending many thousands of pounds more on battery technology in their vehicles than they actually need. So I think range requirements will start to soften in the future, especially for more city type applications where you don't need to have those long ranges. And people will realize that you can buy a cheaper car if you end up with a smaller battery, and therefore that helps to solve the price parity problem. And once we get to that point, I think even in the mainstream automotive circles, you will start to see LFP become a significant part of the industry, because if you're happy with the 250 mile range car, and you can save multiple thousands of pounds by having one with an LFP battery in it, then that's probably where people are going to go in the future. We've already seen that with Tesla in the Model 3.
Yeah, interesting. Some markets where it just really makes a lot of sense to do that. And so you sort of cell format, kind of there isn't a winner, basically. There's a bit of everything, although cylindricals in passenger vehicle, prismatics, commercial vehicle. You touched on, but we didn't talk about it, the sort of cell to pack. What do you make of that? So that's basically been led by these very large blade cells that have started to come out, the blade packs. To me, I look at that and see a lot of risk and complexity. So if the very, very large format cells like that, there's a lot of things you've got to get right with the manufacturing process, and very hard to control. If you've got a problem with one, you've got a problem with the whole pack, basically, which is always the nice thing with cylindricals. They're easy, they're sort of self-isolating in that sense. So I'm talking it down there. I should just shut up and get your opinion. But what do you think of that sort of cell to pack type concepts with a huge cell formats? Do you see that being something that will come in the future?
Well, I think it's interesting because deployment efficiency of battery technology is always going to be a critical thing moving forwards. We need to maintain a good match between range requirements and the capacity that goes into a vehicle. LFP can provide some of those solutions because you can do a greater depth of discharge. Therefore, you don't need to overcapacity the pack quite so much to be able to achieve it. But you do have lower energy density to start with. So cell to pack is interesting because it starts to partially resolve some of those volumetric efficiency pieces. If you can put all the cells really, really close together, then you can really take advantage of that ratio between active material and the actual pack volume. Of course, you've got to use a real super safe chemistry to be able to do that, because the propagation issues, if you're using high nickel, can be quite challenging to overcome. So that means LFP is going to be interesting. Advanced phosphates make it even more interesting, because you're partially dealing with the energy density deficiency by increasing from 180 to 200 to around about 240, which will make those cell to pack solutions super interesting. There are obviously challenges. If you need to repair those packs, if there's some damage, accident damage, for example, it's much more difficult to do those repairs because it's more chassis integrated than sitting in modules or individual cells in a cell. But once we get to that stage, I think some of the activities we've got on the go with EAS in bipolar batteries will provide some significant improvements in energy density. And they are, by their very nature, more chassis integrated than individual cells that are just strapped closely together. Getting to very high energy densities with phosphate type cathode materials is really interesting. And that bipolar solution looks as if it can achieve that. However, all the other companies that have looked at bipolar have ended up with very low volumetric energy densities, whereas the solution that we have in our back pocket doesn't have that incumbence.
So when you say
it's volumetrically very good too.
Sorry, when you say bipolar, what is it you mean by that?
So it's a method of constructing the cells where you have a series count of cells within one container. So you don't have individual discrete cells. You have it all in one container.
Right.
And you're removing a lot of the electrode materials, copper and aluminium. You're putting anode and cathode back to back, and there's a special technique for doing that. You need to create seals between the different anode and cathode stacks to make sure that you don't get a leakage of voltage across. And really, the development activities that have been ongoing in that area internally have really got some really promising results. And that gives us energy density numbers that are significantly higher than even nickel today using a phosphate cathode material. And gives us volumetric numbers that are close to what is achievable today with some of the high nickel materials. So a different approach is giving us a different technical solution. And if we come out to the end of that development with something that looks really promising, it could be globally game changing.
Yeah, no, that's fascinating, that sort of technology. So, it's really clear that there's a heck of a lot going on, like sort of battery cells. I think a lot of people, like with all of these things, people who aren't in the field think, well, surely that's all done and the chemistry is the chemistry and, what you're going to do. But it's really clear right down to the format and the different kind of cell chemistries at fundamental levels. There's still a heck of a lot of activity going on, and you guys are really pushing forwards with the technology side and not just the manufacturing play.
Oh, definitely. And, some of the comments in the past have been, well, if you compare yourselves to some of the big Chinese manufacturers who have got 3,000 PhD students working on battery development, how can you compete with that?
Yeah.
Well, my answer is always give me 60 people who really know what they're doing and we will more than compete with them. Because, that long running history in battery development is really important to understand what is possible moving forward, so you can more easily get through discounting what's gone before that didn't work. And quite often people have said to me, cell to pack, it's something that's new, or cell to chassis, it's something that's new. No, it's not. We did it in the mid-2000s. It's just that the industry wasn't ready to adopt electric vehicles, so we sort of put it on the back burner. And now it's a question of dusting off those plans and those developments and revisiting them again, because we've, for those of us that have been in the industry a long time, we've been around these things before and we've already figured out half of it. So now it's coming back into vogue. It's a lot easier for us to accelerate that and get products out to market.
Yeah, it's brilliant. It's really great to see you doing that, and obviously with that UK kind of base, and for me particularly with up in the northeast, fantastic to see that the benefit that's going to bring to the northeast as a region. Looking forwards, then, actually, I've missed a question. That's probably going to annoy you a little bit, but. We couldn't.
I never get annoyed with you, Ryan. Never.
Oh, thanks, Liz. Solid state batteries, he says, ducking.
Solid state. Yes, that's a really, really great subject. And, as we announced last year, we're setting up an SPV, which will be kicked off later this year with Oxford University and Warwick Manufacturing Group and a couple of commercial partners. Because solid state is something that everybody should be interested in, because it is the potential holy grail of battery technology. I think our bipolar development actually gets us some way there. So that's why it could be game changing, solid state, without having to tackle all the problems of solid state. There's a lot of noise in the industry at the moment about solid state, and in reality, most of the solid state developments, and I'm not going to name companies, are more of a hybrid type solution with a gel or a catholyte type system. They're not really proper lithium metal anode solid state, solid electrolyte solutions. And the reason for that is it's really, really hard to get it right. So you've got surface chemistry problems. You don't have a liquid, you have two very hard flat surfaces that you're trying to push up against each other and make sure that materials interface works properly and is low resistance. You've got dendrite problems as you strip off the lithium and put it back on the charge and the discharge. You end up growing lithium in places you don't want it, and it goes through that solid electrolyte and it causes a short. When you're stripping the lithium off, you create voids, and when you've got voids, you're losing surface to surface contact. These are all significant problems that have yet to be overcome, and that's why our project with Oxford University is so interesting, because the scientists and academics at Oxford spent an awful lot of time understanding why it hasn't worked, and really figured out some fundamental issues that need to be corrected. And we think our solid state program is probably in the best place to solve those challenges, rather than going down the hybrid route, which really doesn't quite get you to where you need to be. So if we do a solid state, it will be a proper solid state battery. It will be a proper solid state solution. It won't be a fudge or a hybrid. And that's why we're investing in it, because we think if we can crack that, it might take a little bit longer than some of the other companies that have looked at the hybrid solutions. But if we can get to a proper solid state system, then it will be a game-changing technology and therefore worth investing in. The intermediate steps aren't quite so interesting, in my view. You're not that much better than lithium ion, to be honest.
Okay, so it's sort of on your radar, but it's potentially something that's a long way off in the future. You think, like, from being commercially?
Well, I think it's on our radar, but it's being worked on.
Okay.
But to work on it properly and create a proper solution rather than an intermediate solution is the way that we want to approach this. So we'll definitely be doing the work over the next 5-6 years. But is it going to be ready and available by 25 or 26? I don't think anybody's going to be there with a proper solid state system in that time frame.
Right. Okay. So that segues in. It does segue in. You'd almost think I did it on purpose, but I didn't. But, so the future, looking forwards, if you had to sort of make some predictions and put some things down, what are you excited about? What do you think we're going to see happening in the sort of near term to middle future? So I'm talking about the next sort of 2 to 5 years. Anything at 10 years time, we'll all be flying around in spacesuits anyway, or teleporters. But in that kind of addressable future, what do you think is going to happen, and what are you most excited about?
Well, I think the thing that really interests me, the things I get excited about was, I've been talking for many, many years that standardization of battery cells is not going to be fit for purpose moving forwards, because you just drive compromise into the applications that they go into. So you need something that's modified and changed and more suitable for those application requirements. And we're starting really to see the momentum building on that now. So I think vehicles going on the road that people are going to walk into showrooms and buy that respect brand attributes and brand values is going to be an important part of the adoption piece moving forwards. I think the maturity of the market for smaller battery packs, where range is not really a need, I think is going to be much more commonplace by the middle of this decade, 2 or 3 years time. So I think that cost of ownership, that cost of purchase piece will be addressed by a certain amount of realism coming into the growth of the market moving forwards, and different vehicles to suit different requirements is going to be a big piece of this moving forwards. I think there's quite a bit of headroom left in lithium ion yet. I think to get to the mid 300s in watt hours per kilo in volume is going to be really interesting. So again, that will reduce pack size. I don't think capacities are going to grow that much more. I think that 300, 350, maybe 400 miles is all that people will need. And there's going to be a big drive into the efficiency of the vehicle, which means reducing weight as much as possible. So that's where I think the energy density comes in and plays a big picture. But more than anything else, I think all these cycle plans that are being announced and brought forwards, and the model range is increasing, is going to create a bit of a crunch for cell manufacturing. There's not going to be enough cells to support the demand moving forwards unless companies like Britishvolt actually, bring forwards their investments and build and put those facilities in the ground.
Yeah.
So my prediction for sort of 2025 and 2026 is that if you're making quality cells of the right performance and safety characteristics, then you will have a line of customers at your door. And I think the automotive industry has just started to wake up to that fact. And that's probably why we're so busy on the sales front.
Yeah, it's got, speaking on the sort of other side of, doing pack integration and things like that, it's definitely got harder and harder to get cell supply. And even for some quite big programs now, the larger cell suppliers can't support it or won't support it. And that is a challenge. So unless you can commit to megawatt hours of cell procurement, you're in a difficult spot. And I've certainly had that issue even with some pretty big brands, because it's people forget it's the automotive, but you've got other sectors like robotics now taking very significant quantities of cells. Aerospace starting to take really significant quantities of cells as well. So there's lots of new markets opening up for battery systems, not to mention huge things like grid storage as well, which I think is we've got to get more grid storage set up to get away from blooming gas. That's going to happen quite quickly, I think. So yeah, it's a interesting time at the moment, and it really, really great to see you guys coming through. So anyway, that's all we've got time for, and I know we've run over a little bit, but thank you for spending the time talking to me. It's been a real pleasure.
It's always a pleasure to come on the podcast, Ryan. It's been great to share some of our journey with you. And although there's a lot that we can't talk about because it's confidential, some of the technology developments and obviously some of the customer pieces we have to keep very confidential. I think we're in a really, really good place to really start to build or take our place in building a European, by European I mean we're still European at the end of the day.
Yep.
Despite past couple of years
we haven't moved the country.
We didn't tow it off into the Pacific or anything, but having a European manufacturing industry is going to be really, really important. And I firmly believe that we shouldn't just be focusing on transplants from other areas of the world. We need to have domestic capability, because we have the talent in this country and within the wider European area to do this. So we shouldn't be relying on China to stand up an industry. And the geopolitics at the moment really means that we really have to do this because we have to be in control of our own destiny.
Yeah, on multiple fronts. Brilliant. Thank you. Thanks a lot, Iz.
Thank you. No problem at all.